All right, let's get into it. We're surrounded by these materials that seem almost like magic. Things that are lighter than plastic, but somehow stronger than steel. Well, the secret behind them isn't magic at all. It's a formula, a hidden formula for strength.
And that brings me to a question, a bit of a riddle, actually. What on earth could an ancient, sun-baked mud brick possibly have in common with a modern, high-tech jet? I mean, they seem worlds apart, right? Well, the answer is the key to this entire story. We're talking about an idea so incredibly powerful that we humans have been using it, refining it, for over 6,000 years. It's been hiding in plain sight this whole time, in everything from ancient huts to the most advanced machines we've ever built. So, what is this ancient secret? Well, it all boils down to a tale of two different materials and one really simple principle. They are just plain stronger when they work together. And that's what a composite material is. It's not about melting things down into some new chemical soup. Nope. Think of it more like building a team. You take two or more totally different materials, you combine them, and what you get is something new, something way, way better than what you started with. And here's the really cool part. The ingredients don't actually dissolve or disappear. They stay separate, they stay distinct, and each one plays its own unique role. It's like a sports team, where each player has a specific skill, and because they're working together, the team becomes practically unbeatable. And on pretty much every composite team, you've got two key players. First, you have the matrix. This is basically the binder, the glue that holds the whole thing together, like the cement in concrete or the plastic resin in a surfboard. And then you've got the reinforcement. This is your star player. This is what brings the muscle, the real strength. We're talking about the stones in concrete or those super strong fibers in modern composites. But again, this is not some brand new idea we cooked up in a lab last week. This recipe for strength is ancient. It's a secret that's been hiding in plain sight for literally thousands of years. The very first composites were about as simple as it gets. Take mud bricks. On its own, mud is crumbly and brittle. And straw, well, it's just flimsy. But what happens when you mix them together? The straw acts as a reinforcement inside the mud matrix, and it stops cracks from forming. Suddenly, you've got a tough, durable building brick. See? That's the principle right there. And once you know what to look for, you see this idea pop up all through history. Go back 6,000 years and you've got wattle and daub, weaving sticks together and covering them with clay. Then the Mesopotamians figure out they can make wood stronger by gluing thin layers together at different angles. Hello, plywood. The Roman Empire basically perfected an early form of concrete, building things that are still standing today. It's not until 1935 that we finally get what we think of as a modern composite, fiberglass. So whether you're looking at the little rocks, the aggregate in Roman concrete, or the crisscrossing layers in ancient plywood, the core idea is exactly the same. You take different materials and you combine them in a way that cancels out their individual weaknesses and just supercharges their strengths. And that brings us to today, because we've taken that simple, ancient idea and we have put it on steroids. We've sparked a full-blown material revolution that has taken us from humble mud bricks all the way to actual spacecraft. The big game changer today is the reinforcement materials we can use. We've graduated from straw to incredible things like carbon fiber. And just get a load of this. That's a single strain of carbon fiber right next to a human hair. It is unbelievably thin, incredibly light, and yet, pound for pound, it is way stronger than steel. It's just mind-boggling. So where do you find this stuff? Pretty much anywhere that performance is everything. The main bodies of airliners, like the Boeing 787, are made mostly of composites to save weight and fuel. You'll find them in Formula One race cars, high-end bicycle frames, and even in the prosthetic limbs that let athletes perform at superhuman levels. But with all this talk about high-tech, glamorous materials, let's not forget the undisputed king of composites. Every single year, we produce about 7.5 times billion cubic meters of concrete. It is the literal foundation of our modern world. And guess what? It's built on the exact same stronger together principle as a simple mud brick. Okay, but here's where it gets really clever. With modern composites, it's not enough to just mix stuff together anymore. Oh no. We've learned that the way you arrange the reinforcement, the direction, matters a lot. This is all about engineering with direction. This right here is the next level of the formula. The real secret sauce to a modern composite's amazing strength isn't just the ingredients you choose. It's the precise, careful, deliberate way you line up all those reinforcing fibers.
This picture explains it perfectly. Think about a piece of wood. It's pretty easy to split it along the grain, right? But try breaking it across the grain. Nearly impossible. Composites are the same deal. If you line up the fibers so they run in the same direction as the force that's pulling on them, the material is incredibly strong. But if you apply that same force from the side, perpendicular to the fibers, it's much, much weaker. So modern engineers basically follow a recipe. They choose their base, the matrix, they select their reinforcement fibers, but then comes the most important part. They figure out all the forces that a part is going to face, pulling, pushing, twisting, and they carefully lay down those fibers in very specific directions to fight those exact forces. Then they lock it all in place, creating a material that is perfectly, and I mean perfectly, tailored for its job. Now, that level of control is already pretty amazing, but believe it or not, it's really just the beginning. The future of composites, well, it's heading into territory that sounds a lot like science fiction. We're talking about the next generation of smart materials. We're talking about materials that can practically think and adapt. Imagine composites with shape memory. You can heat them, bend them into a new shape, and they'll just hold it. Or how about materials with sensors and computers built right into their very structure? They're not just strong and light anymore, they're becoming active, thinking parts of the things we build. And this isn't just some fantasy. This is a real test panel from NASA. The hunt for lighter, stronger, and more intelligent materials is happening in labs around the world right now. From aerospace to medicine, scientists are constantly pushing the absolute limits of what's possible with this stuff. Which really just leaves us with one final big question. The simple idea of mixing mud and straw has taken us on a journey to spacecraft and materials that can think. So, as we keep getting better at this ancient formula, combining materials in even more ingenious ways, what on earth are we going to build next?